All right, let's do 6.2. 34. It says the radial density is 4 over r. Now, if r goes to 0, this goes to infinity. But we know the population couldn't be infinity, but that would have to be right at the very center. And only at the very center, no distance out. So even though this says infinity, we're going to get something on this. Now, radial density means that if you go out some distance, the density per square centimeter is given by, in grams, this is mass, and is given in grams per square centimeter. So we need to know the square centimeters out here. So we're going to go out this some distance and think about a small ring of area. So this is no depth to it, it's just the surface. And the width of this ring is going to be dr because we're measuring out r. And so the area of this, well, the length around of it is going to be 2 pi r. So 2 pi r times dr. So that's the width times the length. That's the area of that rectangle that's bent around in a circle. That's the area. And the area times the radial density will give you a mass, because it's in grams. So we're going to take it times 4 over r. And we're going to integrate this from 0 to out to 2 centimeters. Now here, the r's cancel, and so we can actually get the actual mass of this thing, even though it goes to an infinite mass at the center, which is impossible, but it's what this formula indicates. So we get 2 pi, we can pull out the 4, and then we're just getting the integral of dr, which is r, evaluated from 0 to 2. So all we have to do is put 2 in there, and we get 4 times 2 times 2, which is 16 pi. And this would be grams times centimeters squared, because this is in centimeters, and r is in centimeters, and the dr is, yeah. And the 4 was in, this was in centimeters, this is in centimeters, so that gets rid of the centimeter squares and just grams. Okay, 57. It said find the average acceleration. And, that was over an interval, and I forgot what the interval was here. I believe, so I got to look that up, 6.2. Number 57 said over the interval 2 to 6. Average acceleration, average speeds from 2 to 6. Okay, from 2 to 6. Okay, so to find an average value of a function, it's the integral from 2 to 6 of the function dt times 1 over the whole width of the interval, which is 6 minus 2. So we got 1/4 this integral. And this is a pretty easy integral to do. And so we would get, that would go to squared, divide by 2, so it'd be 30t squared. And this would go to 4 and cancel the 4, minus t to the 4th. Evaluated from 2 to 6. And times 1/4. So we get 1/4 parenthesis. 6 squared is, I'll just put 6 in there. I'm going to have 30 times 6 squared Move that up there. Minus 6 to the fourth. Minus 216. Then minus, I'll put 2 in. So 30 times 2 squared, which is 4, of course, minus 2 to the fourth, which is 16. And that's 104. And I'm subtracting that. And so at 2, the acceleration is 120 minus something. Okay, so this gets me the change in velocity, which is the change in, because if I integrate the acceleration, I get a velocity. And if I find the change in the velocity divided by the change in time, I have the average acceleration. So this will be minus 320 divided by 4, which is minus 80 for the average acceleration. Now, what's the average velocity? Well, if we integrate this, the acceleration, we get the velocity equation to be 30t squared minus t to the fourth. Now that's the velocity equation plus a constant. And if we integrate that from 2 to 4, plus c, but that's going to cancel in it because it's going to be the same in both of them, dt, and then divide it by the, so that would give us the change in the distance divided by the change in time, which is 6 minus 2. This would give us displacement, but we got to be careful because we're not looking for the displacement. It said find the average velocity. Average speed. They didn't say average velocity, they said average speed. So if the speed goes negative, we want to ignore that and make it positive. Now this thing is slowing down. The acceleration is negative. And so it, is it really negative? Yes. Let's see. 60 times 6 minus 4 times 6 to the third is negative acceleration. So this thing is slowing down. Okay? Now, it might have not been negative at the beginning, but it's going negative. Well, velocity wants to keep track of when it's going positive and when it's going negative. This one, the speed, wants to know just when whether it's moving, whether it's going forward or backwards. So we have to find out if this is ever 0. Well, it's 0 at time 0. If you factor out t squared, and find out if it's ever 0, well, that would happen at 0 and at, 30 equal t squared, so at the square root of 30, which is a little over 5. So instead of going from 2 to 6, we need to go from 2 to the square root of 5, a square root of 30, and figure out what this is. And if it's not positive, we'll make it positive. And then we're also going to do it from from square root of 30 to 6 of the same thing. And if this is not positive, we'll make it positive. So we get a total speed, and then we'll divide it by 4 to find the average speed, or the total change in distance. The total change in, distance, not displacement. So we got to work this one out. So this integrated, that would go to 3, so that'd be 10t to the third minus t to the fifth over 5. And we've got to evaluate that from 2 to square root of 30, and then again from square root of 30 to 6. So I need to put several things in here, so I'm just going to do it this way. I'm going to type in, and we got to times it by 1. Let me write this out here so you know what I'm doing. I got to evaluate this from 2 to the square root of 30, and then take the absolute value of that, so we're just getting the change in distance, plus the integral from square root of 30 to 6, absolute value of the same thing, 10 t, not integral because I've already done the integral, 10 t to the third minus t to the fifth over 5, evaluated from square root of 30 to 6. Take the absolute value, and then 1/4 of that to get the average. So I need to put in 2 square root of 30 and square root of 30 and 6 into that expression. So I'm going to go to the y equals and type that expression in there. I'm going to type in, I'm going to turn off the plot too, 10t to the third, 10x to the third minus tx to the fifth divided by 5. And there's my expression. Then I'm going to go second table set and make sure it's on ask, and then go to the table, and I'm going to type in 2 and square root of 30 and 6. So this one, when I put in the square root of 30, I'm going to get 657.27, and when I put in the 2, I get 73.6, and if I subtract those, that's positive, so I want that. Kind of hard to read my writing because I was reaching over the calculator. And then on the other one here, I'm going to put in the square root of 30, which is the 6, which is 604.8 minus 657.27. That's negative, and so I want to do the opposite of that one. So from this one, I get 657.27 minus 73.6, 583.67, and to that I want to add the other one in positive, so I want to subtract them the opposite way, so I'm going to go plus parentheses 657.27 minus 604.8, close parenthesis. So the total for this one plus this one in absolute value is 636. Then I got to divide that by 4. So the average speed is 159.035. There's the average acceleration, and here's the average speed. Now, if it was average velocity, then I wouldn't worry about these being negative. I would have subtracted that amount. Okay, that's that.